So as long as you know what the area of the cross section is, you can find the volume by just integrating across what the boundaries are here. So for this thing, this area underneath here from 0 to pi, again, hard to draw. We'll use that other applet thing in a second, but if the cross sections are squares, so you have squares that are that length on the side, that's the y value, right? I really think it's a good idea to draw the side of the square like this is that, right? You have squares rising out of the page, and the side of the square is how long? How long is the side of the square? Well, you could write y times y, but we want it in terms of x. So how long is the side of the square there? Sine x times sine x, right? So the function is going to be sine squared. So we want from 0 to pi. The area of the cross section is sine squared x dx. That one you're going to have to do on the calculator for yourself.
Yes. I am. New operating system. Pretty good.
Can we leave the actual calculating it for a second here and set up the other two as well first? If you set this up so that these are semicircles, right? Like if that's a semicircle on there, you have a semicircle that is, if this whole length here is sine x, what's the area of that semicircle? Well, the semicircle is there so that the radius is actually half of that, right? The radius is not sine x, it's sine x over 2, or a half sine x, right? Because the semicircle's right there, right? Those are the circles like that, so half circles. The radius is a half of the sine value. A radius is a half of the y value, right? The radius is a half of y. So what's the area? The area is a half y all squared. The cross-sectional area. Right, it's a half y squared, or in other words, a half sine x all squared. But that's if it was a full circle. What do I have to do if it's a half circle here? There's lots of halves involved here, right? It's a half of that. It's a half of a half of a half. It ends up being like it's an eighth of, and I forgot my pi in there, didn't I? Somebody must have. Another rookie mistake. So anyways, then if we want our volume here, it is integral from 0 to pi of
1/8 sine x.
Pi, yeah, and we can put the pi outside. You can put the 1/8 pi. I'll put it all in here for now, so we don't lose track of it. Pi over 8, I guess you could even say. Sine squared x dx. Okay. Yes. The hard part is setting it up. I mean, putting in the calculator is not the important thing here. The answer before, we have not worked out either one here, right? Put it on the calculator, see what it tells you. You're guessing? Well, the area of a circle is pi r squared, but the radius in this case is half the y value, right? Because it's this distance in here, and it's a half circle, so it's a half pi r squared, and the radius is a half of y. So that's where all those halves come from. Let's go to here to have a look at it in a second. Okay, first of all we have a circle here, or a square. We'll do the one with the square. F of x can be sine x, and the other one is, it's to the axis, right? So that. The limits here are from 0 to pi. Well, is that close enough for you?
I think there's a couple more digits after that.
There is a couple more, just a couple more. If we go up to 4, this should show it reasonably enough, right? Not now. Okay, so again, it's hard to see that it's meant to be a square coming out of the page, but that's what that is, right? It's hard to visualize what this would look like. It would come to a little point at the end, right? Little pointy shape on each end. The volume, does this match what you got? That is what you got? That is actually pi over 2 by the looks of it, 1.57. And you can do the same thing with the semicircles. Get the same thing. Or you don't get the same value, but you get the same idea, right? The last one I put in here, same concept, right? Just maybe try to set it up for yourself here. Why would I do this to you? Do what? We'll pause. Okay, what would this be? Integral from 0 to ln 2 of the base is that region, and the cross sections perpendicular are squares. The length of the side of the square is how long? The difference between those functions? E to the x minus e to the negative x. So it's that squared. Dx. It's the length of the side of the square is that, right? The difference between them. That's what the sides of the squares are, the difference between them. So whatever that gives you on the calculator. What does it give you?
Hey, Mike. Was I talking to you? Yeah.
I'll just pause this while you
Argue?
That's right.
0, 2.
Integral from 0 to, what was it, ln 2?
Oh, there I got it. Squared. We're using it as a square.
I got 0.5. The answer is 0.489.
Anybody agree with that? 0.5?
No, you didn't square it.
Oh yeah, I didn't square it.
Yeah, you did the same thing as you were. Wow.
Whoops. I can square. I can. Oh. Why won't it?
You got to go up to the. Go up. Press up. Button. Oh, take away alpha.
Take away alpha.
Go up.
Just go up.
Up.
Oh, nice.
Press enter.
I like that.
There you go.
That's different than it was before, eh?
A. Oh, you said A. 0.4.
Oh, I need 2 sets of.
Put another bracket in.
I know it's.
Where is my insert?
This is insanity, though. I need 2 sets of brackets, even though you really don't.
The new software. She would like that new software.
I don't think I'm all that old, but I never thought I'd live to see the day when we talked about software on a calculator.
Yeah.
Oh, you got it right.
There you go.
I got it right. Thank you. Now, can I write it down properly? What was it? 488 something?
Hey, do you know
489.
how much
489?
the school spends in photocopies every year?
15,000.
No, that was
No, that's what they say.
What did they